Welcome, dear all students. This is the third problem of class 10, lesson 5, that is the sound lesson. Okay. Doppler effect problems. Third problem, book bag problem. Now, you have to understand the question very well. A source of sound is moving with a velocity of 50 meter per second. What is the velocity of the source? It is 50 meter per second. Vs is 50 meter per second. Okay. The observer is stationary. So you can put the value of V0 as 0. Okay. The observer is stationary. Here, see here, the observer is stationary, 50 meter per second. And what is the source frequency here? It is 1000 Hz. You have to approach this problem into two categories. Listen, see here, the observer is stationary. Before that, you are having one set of data. Okay. After that, you will be having one set of data. This problem you have to divide into two categories. One is that the observer is stationary and the source moving towards the observer. And the source moving towards the observer. First part. And the second part is that the source is moving away from the observer. So in both the cases, n dash will be the same, but you have to find out the value of the n and then substitute the value of the n in the second one. What is the question? A source of sound is moving with a velocity of 50 meter per second. We are having all type of data, Vs, n. So you can find out the value of n. With this n, substitute the value of the n in the second part. That is, the source is moving away from the listener. Before that, we have to find out the value of n. Then the observer is stationary and the source is moving towards the observer. Okay, now it is very much clear. Let us come to the problem. We know the value of n dash is equal to the general part is n dash is equal to V plus or minus V observer by V plus or minus V. Yes. Okay. In this case, you consider the source is moving towards. In this case, the source moving away from the observer. Okay. So, if the source moving towards the observer, what will be the value of n dash? It should be maximum. If the value of n dash is maximum, what will be the value of denominator? It is minus. Since the observer is stationary, you can put the value of V naught as 0. V by V minus Vs into n. What are the data given? 1000 hit, it is n dash, and 330. 330 it is usually the value of the sound waves in the air, 330, and source velocity is 50, and substitute the value of 50 here, and you have to find out the value of n. Then the value of n is equal to, then you can find out the values of n like this. 1000 into 330 minus 50 is, what is the value of 330 minus 50? It is 280, 1000 and 330. Okay, strike out all those values. Then you will be getting the value of 848.48 kits. Calculate the value of n using a calculator or using logarithmic table. You will be getting n is equal to 848.48 hits. Okay, the actual frequency of the sound is 848.48 hits. Okay, now you have to consider the n dash when the source is moving away. Okay, when the source is moving away, the apparent frequency will be decreasing. For that, the apparent frequency to decrease, you have to put the sign of plus here. Okay, here you have to put the sign of minus because you want the apparent frequency is minimum. Is it not? This is logically increasing and decreasing. Okay. N dash is equal to V by V plus Vs into N. Substitute the corresponding values. 330 by 330 plus 50 into what is the value of N here? 848.48. Okay. Substitute it. Then you will be getting N dash is equal to 736.84 Hz. I think you understand this problem very well. If you find it very difficult or if you have any doubt, comment in the comment box. Let us see in the next problem.